going through a detailed construction of the sine graph. I've already bisected the right angle between the positive x and y axes, and I've in fact constructed the bisector of this angle here. And the construction isn't completely accurate due to the fact that I don't have the most accurate possible instruments, but I'm going to demonstrate the process. Okay, so I'm wanting to bisect this angle, and I do so by making a light arc here and here. And then I do the same thing from this point. And I'm not going to go into the details of the proof, but these 2 points should lie on the bisector of this angle. Now, as it turns out with these instruments, the bisector of this angle, of course, has to go through the vertex, which is at the origin. And if I draw a line from this point to this point, it should go through the intersection of these 2 arcs. Now I'm going to make those arcs just a little clearer. And it's pretty clear that I'm falling a little bit below this arc. The same thing happened when I did this one and this one. And that could be for any of a variety of reasons, and you're welcome to speculate. So my construction isn't perfect, but we're going to assume that the process I'm using, if done with complete accuracy, is going to lead to a perfect construction. So at this point, I've started with this angle, which I assume to be the bisector, probably off by a couple of degrees, of the right angle here. And that right angle isn't perfect either. Then I bisected this angle, and I bisected this angle. So we know how this is going to be used in constructing the graph of the sine function, but I want to show a few more details of that construction. So I'm going to continue with this shortly, or possibly in an additional video. Continuing with the construction. Again, piece of chalk stuck on a metal point here. I'm not totally confident that it's going to last. It looks like it's already wiggling a little bit, but let's attempt to mark a couple of points here. I have to mark these very lightly. The chalk here really doesn't want to stay there very well, and if I put any significant pressure, now, I can see right away that these points are not aligned with the origin. So I really don't know why I'm getting these results, except, of course, that because of the chalk on here, this distance is a little bit different than this distance. Just curious whether that, well, I kind of lost it, results in a distorted circle. You might think about that. Okay. In any case, if we believe this construction, which is clearly not very accurate, we've bisected this angle. Now, I'm not going to draw the bisector of this angle and this angle and this angle, but it's clear that I could. And I appear to have lost my chalk. In any case, that's the bisector of the next angle. And I could continue bisecting these angles. Now, there was no point in you watching on camera while I drew the rest of these bisectors. And I didn't actually construct the rest of these bisectors. I really eyeballed it. Remember, this angle and this angle, there's nothing in between. I simply looked at the halfway point, then halfway from here to here, and halfway from here to here. So there are discrepancies in the way I eyeballed these things. However, it should be clear that if we had completely accurate construction tools and knew how to use them with complete accuracy, we would have obtained a good set of, an accurate set of points on the circle. Now, as you know, to get the graph of the sine function, we have to project these points, excuse me, onto the y-axis. So, how do we do the projection? Well, I'm going to choose this point here. Okay, this point on the circle. And I can make an arc here and here. And I've already done this just in case the chalk falls off of the compass, which is probably reasonably likely. Okay, now I've just drawn these arcs. And just to make them a little darker, and maybe to put them in a contrasting color since it's a different type of construction, I drew this arc, constructed this arc, this arc. I kind of messed that one up, but the intersection point is here. Trying to make these things too curvy. And here. Okay, so you pretty much see where these arcs were. And it's no coincidence that the actual arcs I drew, little red arcs, and you can back up and see if you want to, really do intersect the circle here and here, at least within the thickness of the chalk mark. And without comment, I'll say that the line connecting these points will be perpendicular to the y-axis and also goes through the original point that we were trying to project. So my projection line, again, I'm dealing with the thickness of the chalk, so there's going to be some uncertainty in the actual location of this line, but we get a line like so. And the y-coordinate, of course, or the y projection, we don't even want to talk about coordinates when we're constructing a graph, it's going to be this. So now we're going to assume that we've done that for all of these points. And I'll continue the video or do a separate video indicating the construction of the sine graph. Now I've constructed a horizontal and a vertical axis here. I don't even want to call them X and Y because of confusion that can arise between what X might mean here and what it might mean here. So I'm not going to give these axes names at this point. Okay, now this is a quarter of a circle that I've divided up. And as you know, if you know the general procedure for constructing a sine graph, I can use symmetry to construct the sine graph for this quadrant, and this quadrant once I've got this one constructed. We're going to do the details of that. Okay, but right now what I want to do is, since I'm going to want to construct this for 4 quadrants, I'm going to want to divide the x-axis up into one, and I called it the x-axis, didn't I? The horizontal axis into 4 segments. Okay, so I believe you can see those marks, but let's just mark those 4 points. And now I've subdivided this interval. I did one subdivision, then another subdivision here and here, and another subdivision and another one. So I did a total of 4 subdivisions. So if I divide this interval 4 times, iterate the division 4 times, or iterate the bisection 4 times, I'm going to get the same number of points here that I have here. So I'm going to go ahead and do a little bit of that. Okay. So right there's our first subdivision. And I can draw the bisecting line. Again, it's not perfect. Again, these points didn't really, I think, align very well at a perpendicular, but maybe I'm not seeing it right. So anyhow, this is about where it ought to be. And then I can divide each of these intervals in a similar way. And naturally, this is a little tedious to watch, so if you already know how to do this, if you're sure you know what's going to happen, you can skip ahead a bit. If we're dividing this into a bunch of shorter videos, then you're perfectly safe if you want to skip to the next short video. If this is one long video, skip ahead a few seconds. Okay, now again, this is imperfect. My instrument is not completely accurate, but right there is a subdivision. I can see with my eye that there's problems with this subdivision. It's not really very equal. However, we're going to assume, again, that this is being done with completely accurate instruments, and completely accurate instruments used with complete 100% perfect precision, which is of course physically impossible.